Hi, hello everyone. Welcome back to our lab class. So far we have done the 6 labs. So the last 2 labs is about the head loss in pipes, and then we have already discussed the pipes in series and parallel. So today we will learn how to design a pipe network. Okay, how to analyze the pipe network and how to design the pipe network. Probably you have read in the class, in your theory class, that how to solve the pipe network problem, but in this lab uh, we don't use any equipment or experiment. We will use the software, so hopefully you will enjoy most due to the software work, and I have a little bit changed my video backgrounds, so because of a little bit messy in my room, so I don't share with this one to you. Okay, let's get started. Okay, so far we have done our head loss. So you can see this is slide from the previous labs, and then we have already run how to looks what what is the flow looks like for series and parallel. And then today we are here to show you how can we design the pipe network. So do you have any idea of pipe network? Based on the very fundamental principle, so that is called the Hardy-Cross method. So Hardy-Cross first proposed a method to solve the pipe network problem. So what is that method? So the two law. So if you just recall from your high school, that is the electric circuit. So there are two laws, the Kirchhoff laws, right? So Kirchhoff first law and the Kirchhoff second law. So which is, I remember from my high school, that is called KCL and KVL. So Kirchhoff said, in a circuit at any joint, the inflow of current and the outflow is current is the same. In other words, if I show you a parallel connection, say parallel connection or series connection, so if you look at any joint, so the summation of inflow and the outflow is basically same. So that is the first principle of Hardy-Cross method. And the another principle is that the summation of head loss in a closed loop is equal to 0. Okay, so that is the main basic principle to solve a pipe network. And obviously, so for the head loss we can use any formula, Darcy Weisbach, Hazen-Williams, or Manning's, or anything. So today we will use the software. That software can handle every formula as you wish and every material. So what is that software? The software name is WaterCAD. So this is very useful software for you if you want to do future project work, some kind of water distribution or pipe network or everything or anything. So then that software will be very useful to you. So WaterCAD is kind of a software like the combination of AutoCAD and kind of GIS. So the basic difference in AutoCAD, you can only draw, right? But this software you not only can you can also draw and also run the model, also build the model and run the model to see what is your also you can predict the flow in pipes and what will be the size of the pipe, what will be the properties of the pipe, and what will be the head loss and flow and everything. So let's get started to see how can we build a model in WaterCAD, and how can we run the model and predict the necessary parameter to design the pipe network. Okay, so this software is not free, so you have to buy from the Bentley. So in the last year I have already teach this software in the UCF, but due to this COVID-19, so we cannot go to the lab to show you. So far but I think the software company has already provided free license for the student. Although if you are unable to get the license, just you can follow my video and summarize the procedure, so that will be for the that will be sufficient for the lab 7. Okay, so let's see how can we build a model in WaterCAD and run the model. Okay, so first take a look the problem definition. So there is a layout. I can show you from here. So this is, what is this? This is the layout for some homes, right? Okay, so for this housing system we have to design a pipe network system. Okay, all right. So what is our problem? So our problem is we have to propose a camp, part of which will receive its water supply from a tank, and you have to design the water distribution system for the subdivision to the left of the layout shown using WaterCAD. Okay, and there are some parameters, and our in your design you can use, like, your average daily demand is 40 GPM, gallon per minute. Okay, so let's see how can we design a water distribution system for this household on the left side, and based on some criteria. So what are the criteria? So if you look at your lab manual, so there will be 10 pipes and 8 junction. So for the 10 pipes, they have the length and they have the material and they have the diameter and everything, and for the junction they have elevation, and there are some other parameters for the tank as well, say for example the diameter of the tank and minimum and maximum elevation of water in the tank. Okay, so let's see how can we build a model for water distribution, and then we can propose some design, and eventually you have to fill up this summary table, so which will be your results for the labs. And let's see, so this is called the layout. So if you go to the web course file section, then you can see there will be layout, so you can import this layout in your WaterCAD system so that you can work on that and build your model. So let's see how can we build the model. Okay guys, so now I'm gonna show you how can you download this software. You can simply open your browser, then you can say type BNTLY. This is the software company, so I have this link. So when you go to this link, then you can, so here is their software, so you can search their product. They have so many engineering products, different types. So we need hydraulics and hydrology, right? So they have different types of software, so but we need this one, right? OpenFlow WaterCAD. So how can we download this one? So first of all, you need to open an account here. So usually this software is not free, this need license, but due to COVID-19 I think they have opened a free license for the students. So when you need to open an account, so you need a school code. So if you contact them asking a school code, then they will provide you the school code. For example, this is my school code. Okay, so I can simply submit, and then when I submit, then I will be able to log in my account. So this is my account. Okay, so go down, you can see there are so many software. So then click on software downloads. When you click on these downloads, then it will show you different types of software. So let's see how many software they have. So they have MicroStation, Stat Pro, and everything. And so just look at this. Is basically we need the OpenFlow WaterCAD. So when you click on it, will download, and then you can simply install in your computer. So but when you open this software, you need to connect this one also, right? Okay, so if you don't able to connect, that's fine, you can just simply follow my procedure. But if you can install this one, and I think this free license is valid through August. Okay, so if you can install this one, that will be helpful for you in future and to learn this software. Okay, so I have already downloaded this software in my computer. If I type here just WaterCAD, so you can see this one is a WaterCAD. If I open, just there will be a new window here. And okay, so this is the software, and first of all you need to create new hydraulic model. Okay, and when you click on new hydraulic model, then you will see this window. Okay, so it will take a few times, a second I think. Okay, then click no. Okay, okay, here we go. So this is the software for WaterCAD. Now we can build our model using this software. So I'm going to show you how can we work on this software. Okay, so this is basically the WaterCAD software looks like. So you can see from here that there is so many toolbars here, just like the other software. So for example, file, and you can save anything from here, and layout, analysis, component review, and so on. Okay, so how can you browse this toolbar? You can browse this toolbar from here, kind of, and from here you can also draw a different types of symbols, say for example pipes and junction, hydrant, tank, and so on. Okay, so so this is basically WaterCAD software. So as you see from here, license for academic use only. So you can simply this is the icon for WaterCAD. So I think this year they changed the icon, and you can simply Google it like Bentley WaterCAD software free download. Then you go to that link, and then register with your Knight's email, and they will give you some codes, and based on that code, then you can download this WaterCAD software. Okay, so I will let's see how can we use this one. And first of all, we have to build a model. So before building a model, we have to fix something, some kind of unit system, some kind of, you know, the previous stuff. So go to layout, to options. So this is basically WaterCAD software, right? Okay, so I'm not gonna tell you to download this software and work on this software, but if you can, that will be good for you. So for the report, I will ask you to summarize the procedure for this software and everything, but if you can download, that's fine. Okay, so because sometimes, you know, there is a trouble for opening account in Bentley website. So for example, I had a trouble, then I emailed them, and I got answered their email after 2 or 3 days after. Okay, or then maybe it might be take 2 or 3 days to open an account and access the software. Okay, but in UCF there is a student version free software. You can go there and you can work on that, but due to COVID-19, most unfortunate for us, So let's follow this video and to see how can we work on this software. Okay, all right. So first things first, just like every other software, it has so many toolbars like file, so you can save this project. Okay, then home and layout and so on. So first of all, we have to build a model. So it's unlike the AutoCAD. So although the name is WaterCAD, but unlike AutoCAD, in AutoCAD we can just draw, right? We cannot run a model, but here we can draw a model and build a model, and then we can run and calculate everything do we need. So what we have to do, we have to design a pipe distribution network. Okay, now I'm going to show you how can we build a model. Okay, so first things first, we have to fix the unit system. So for example, how can I do that? So go to tools, to more, then options. Okay, all right, then you will see this window. This is called the option window, a new window pop up. So in this window, basically you can change the appearance of the software. Say for example, background color. Now if you look at here, the background color is white, right? So I can change it from here, whatever color do you want. Okay, all right. And every other thing like display, auto refresh, if you can on it and off it. Okay, so then pixel, and then width of the line. So if I want to show you very big line, very thick line, then I have to change this one, right? And there are two options here, default drawing style for new file. There is a option for CAD and there is option for GIS, right? So for example, if you are working on a real project, the real one, you have the special reference, you have the GIS file and everything, then you can select the GIS and then directly import it file from the GIS or shapefile that you have for the project. Okay, but now I am selecting CAD. Of course, you can also directly import file from the CAD. Okay, AutoCAD for example. Okay, so but for this lab, I'm going to show you a very simple water distribution network. So I'm selecting CAD to draw, to show you very simply. So okay, so these windows have so many toolbars. If you look at here, global, we can select CAD, then hydraulic model, there is a called spatial reference. So if you are working on a real project, for example, if you are working in Florida, Orlando, then Florida Orlando has any spatial reference, then you can select this one. And if you want to specify where to save your file and everything, file format, what should be the file format, then you can use this one. But we don't need this one because I want to show you a very simple thing. Okay, but of course you can search here and you can download in your computer, then you can play with this one and everything. So round length to the nearest 0 feet. So I want to give you some round figure. Okay, so then go to drawing. So you don't need to change anything here. Then go to drawing. There are two options, scaled and schematic. So if you select scaled, then you have to define the scale. For example, what is scale? For example, if you draw 1 inch line here, okay, then you have, that will be your 40 feet or 100 feet. You can change your say 90, 900, even so on. But I can select here schematic. What is the purpose of schematic? I can draw just like AutoCAD. And then we have to define what is the length for pipe and tank and everything. Okay, of course you can see there is a pipe, junction, tank, reservoir, and so many things you can draw. Okay, so if you want to show very bigger size, then symbol size multiplier. If you want to I want to say, for example, I want to show you a very big symbol of tank, very big symbol of pipe, so then I can change it to 5. Okay, and I want to show you very large text, so maybe I can use 5 also here, and then go to units. So for example, I can select US customary, and then I will show you later the what is the purpose of labeling and everything. Okay, so here the very important thing, you have to define your unit US customary and then drawing to schematic, because we are I want to show you very simple network just like AutoCAD. Okay, then click make sure your unit is correct, then click OK, then your unit is fixed. Okay, and you can see there are a lot of prototype here, for example pipe, junction, hydrate, tank. Okay, so if there is any question, just you can ask me to the web course inbox. Okay, if no question, then I can proceed. Okay, the next step will be when you are done with your units, and then you have to define your prototype. So how can you define your prototype? So first use the analysis, is the layout, and layout again from the layout to prototype. Okay, so if you see your lab manual, so there are 3 kinds of prototype do we need to model. Okay, so one is pipe, another is junction, and another is tank. Okay, so here you can click on the pipe and right click, then new. Okay, and then click on the junction, right click, new. Tank, right click, new. Or you can simply double click here. Okay, so then you can rename your prototype. Say for example I said pipe prototype, let's remove one here, then you can remain, this is our junction, this is our tank. Okay, all right, so just want to make sure they are not messed up. Okay, and if you are working on a real project, you have so many other prototype. Okay, so then when you define your prototype, say for example pipe, junction, and the tank, then double click on the pipe, or you can click on this pipe and right click, then properties. Okay, so then there will be another new window pop up. Okay, all right, so then look at this new window. So this is called pipe property window. Okay, all right, so what we are interested in here, so you have to tell this software everything. Say for example, is there any failure history for this pipe? Answer is no, right? So number of breaks, local duration, and first of all how many what are the 3 kinds of property for the pipe has. Okay, so physical property, water quality, and so many other properties. So for example, if I select the diameter, that is 6 inch. Okay, so in your lab manual you can say there are 6 inch diameter pipe we have to design. Okay, so material. Okay, then you can see what default material is ductile iron. So we want to show you with PVC, so then you can select this, and there will be another new window that is called library, material library. Okay, so double click here, and this software has a very strong material library. So for example, if I click on P, it will show you PVC, right? So in the right side you can see what is the property for the PVC pipe. Say for example, young modulus and Manningsen, Hazen-Williams C. So when you select a PVC, the Hazen-Williams C is 150, right? Okay, what should be the Poisson's ratio? And for a pure PVC pipe, the Hazen-Williams will be 150 and Poisson's ratio and everything. Okay, so we can select PVC pipe here. Then you can see here Hazen-Williams automatically changed to 150. Okay, so has user defined length. Yes, because when we use the schematic we didn't define any length yet, didn't define any scale yet. Okay, all right, so we can change from false to true. Yes, we have user defined length. Right now there is no pipe and we didn't define any length yet. Okay, all right, so let's say every other thing is as it is. Has any check valve? No, right? Okay, no check valve. Okay, all right, specify local minor loss. Is there any minor loss? Yes, true. Okay, and then minor loss coefficient here, if you have any minor loss coefficient you want to use, then you can change it from here. Okay, then web speed. Okay, then you can select the water quality parameter, but we don't need it right now. Okay, then we can simply close this table. We have done with our pipe property, and then go to the junction property. Similarly, there are another window pop up for the junction table, so you can select what should be the demand collection. Okay, so your lab manual says our demand collection will be 40 GPM, gallon per minute. Okay, so remember your house is always connected with a junction. Okay, all right, then click here, then demand base GPM, let's say 40. You can see fix. So if you right click here, global edit, you can set 40 here as well, so that make sure our demand collection for every junction is 40. Okay, all right, so if you want to change unit from here, so say for example you have another demand which is let's say not in GPM but this one, milliliter per day, so you can change unit from here. Okay, but GPM is fine for now. Okay, so unit demand collection we don't need to do anything here, but if you have any elevation you want to use, then you can input here, but we will use the junction elevation later. Okay, and if you have any water quality parameter for the junction, you can select it also from here. Okay, then close this table. Similarly, go to the tank table. We have to define the demand for the tank as well. Let's say it is same 40. Right click, global edit, set 40 here as well, then click OK. Okay, all right, so there is no minimum, initial or maximum elevation here, but we can select it later. Okay, all right, now everything is prototype is done. Now when we're done with our prototype, then we have to browse our layout here. Okay, so let's see how can we now draw our model. Okay, it's time to import our layout. Okay, so in the left side there is a small window, so this is called the background layer. Okay, so you can simply click on the background layer and then right click, new, so file, to browse, you can browse your layout here. So I have already downloaded in my computer, so there is a say lab 8, so let's say we need to change it, so it will show you is this the coordinate do you want to import your layout. If you don't know anything about coordinate, then you can simply click OK. All right, so this is your layout. Okay, let's say how does it looks like. So I want to show you again, guys. Just right click here, new file, and then browse your layout here, just to open, then it will show you the coordinates. Okay, and to make sure, you can just check out and click here, and it is your layout. Okay, so it looks like nice. So we have to design a distribution network somewhere here, right? Let's make it more. Okay, now it is clear. Okay, all right. Obviously you can rename your layout, say this is not lab 8, this is lab 7, let's say 7, or you can simply, you can write my layout. Okay, all right, now it's time to draw our network. How can we draw it? Okay, we need to toolbar, right? Tools. Okay, so more, now we have to draw tank first. Okay, so go to layout, click on the tank, and maybe I can put a tank somewhere here. Okay, so you can see T1. Okay, all right, now you can select pipe. So say how many pipes are there? 10, right? This is your pipe 1. Okay, then like go down, this is pipe 2, then pipe 3. Okay, then pipe 4. All right, then right click, done. Okay, now click on the junction 3, the top, pipe 5, let's say this pipe 6, then right click, done. Click on the junction 5 again, then right, then down, then left, done. Click on the junction 7 again, and pipe 10. Okay, if I press escape, okay, and out of the checkbox, so this is your network. This is called the layout. So how many pipes are there? 10, right? So you can see from here junction is automatically created again. So when I draw tank first, then pipe 1 here, pipe 2, pipe 3, pipe 4, and from here pipe 5, pipe 6, 7, 8, 9, and 10. Okay, it doesn't matter from where you start and where you end, but if you want to match your result with me, then you can simply follow my sign convention, right? Like pipe 1, pipe 2, pipe 3, pipe 4, and then from junction 3 to junction 5, pipe 5, 6, 7, 8, 9, and 10. Okay, how many junctions are there? 8. Okay, so this is our layout. Okay, now before we start, we didn't define any length. So if I ask you what is the length for pipe 2, the answer is 0, right? So there is no length right now. So now we have to define our pipe length. Okay, now let's see how can we define our pipe length. And for the junction we need to define the elevation. Okay, so how can we do that? We can do that simply from view to flex table. So if you go to view to flex table, then click here, then there will be pipe table, junction table, and the tank table. Okay, so look at the pipe table first. Okay. All right, you can see some of the columns are yellow and some of the columns are white. So white means we can edit on that. Okay, so now we have to define the length of this pipe, and then we have to run the model. So let's see how can we write the length of each pipe one by one. Okay, how many are there? The 10. Okay, now if you look at your lab manual, there is a table that we can use for the length of the pipe and the elevation of the junction. Okay, let's see how can we do that. Okay, so go back to your lab manual, so you can see there are a lot of length in your lab manual. So we have to input this one, so that is the length of each pipe. So let me input this length here. So let's see from your lab manual. So this is our pipe, say 410, 560, 300. We have to input this one, 460, and then 510, 300, and then what else? 545, 560, 600. 545, 560, 600. Okay, so then 280, 560, 280, 280, 560, then 280, 545, 280, 545. Okay, so this is all our user defined length, and then we don't have any check fault, right? Okay, then we can close this table. And for example, if you are working on a real project, you have simply Excel file you can directly import from here. Let's say import here, just like the Excel file. Okay, so now I can close this window, and then we have to go to from view to flex table to the junction table. So here you can see from the junction table we have to define the elevation, right? So for the junction we need elevation. If there is no elevation, then there will be no flow, right? Okay, so let's look at your lab manual. 620, 560, 560, 620, 560, 560, because we are manually inputting the 5 to 5, 580, 618, 5 to 5, 580, 618, not 80, 618. Okay, 560, 5 to 5, 560, and then 5 to 5. Okay, then we are done. How many junctions we have? We have 8 junctions, and now you can see then there is no pressure at each junction. When we run the model, then the software will show you how much pressure in the junction 8 or junction 7 and so on. Okay, all right, now I can close this window and then go to view to flex table to tank table. Okay, so we have to define what will be the diameter of the tank. The diameter is, you can see from your lab manual, is said that 60 feet, and these are the minimum and maximum elevation. So 60, let's say 60 feet, and then what is the minimum? Minimum is 680, 715, and 730. 680, that's the minimum. So why do we need minimum? So if your water level goes beyond this limit, then software will stop the iteration. Okay, and then initial 715, then maximum elevation is, let's say, how much? 730. Okay, all right, so that's all for the tank table. then we can close this one. And now we have the layout, we have everything for pipe, junction and the tank. Now is your model is ready to run. So before run this model, we need to validate this model to make sure everything is correct. Okay, so let's see how can we validate this model. So to validate this model, then you have to go to this analysis toolbar. Okay, then click here. You can see there is a button compute. We don't need to use this button right now because first things we need to validate. Okay, so how can we validate? Here it is. So analysis to validate. So if I click the validate icon, then the software will show you then no problems are found. Okay, that means your model is ready to run, everything is fine. So if there is an error, then you will see a red symbol here. Okay, so now I can run my model. So from analysis, then compute. Okay, let's see. So everything is green, that means my model is okay. So if you look at here, then there is 5 trial needed for to run this model. So what does it mean? It means when you use the hardy cross method, there will be 5 times the software network will iterate to optimize your solution. Okay, so if I close this one, then you can see the flow direction. Okay, so now what is our purpose? Our purpose is to complete this table that is called the summary table. If I make it more zoom, like you can see, so now this summary table asks you model run results. So pressure at junction 1. What is the pressure at junction 1? Now we have to go to the junction table. How can we see our results? From view to flex table, then junction table, then this junction table show you how much is the pressure. Okay, so pressure at junction 1 is basically 40 psi. If you wanna change your unit, then you can change from here psi to say pascals, then it will show you in pascal. Okay, so it depends on what do you need to do for the design. Okay, so now you can, I think you can complete the pressure. What is the pressure at junction 1? That is 40 psi. Pressure at junction 3, that is 65 psi. Okay, the pressure at junction 7, how much? 65 psi. Okay, and HGL at junction 5. So where is the junction 5? This one. What is the HGL? Hydraulic red line. Okay, so 710.91 feet. Okay, now next one, velocity in pipe 1. So this is the junction table. We can close this one, and then from view to flex table, then pipe table. Velocity for pipe 1, pipe 6. Okay, so you can see for the pipe 1, the velocity is this one, 3.63 feet per second. Okay, for the pipe 6, velocity is how much? 1.61. Okay, pipe 6, 1.61. Okay, discharge in pipe 2. So what is the discharge in pipe 2? Pipe 2, the discharge is flow, right? 139. Okay, 139. Discharge in pipe 10. Where is the pipe 10? This one. It's 40 GPM, right? Now if I ask you why the pipe 6 discharge is negative, now look at this layout. When I draw the pipe for pipe 6, we draw from this way to this way, right? If I zoom in, from junction 5 to junction 1, but flow direction is opposite, right? That means our assumed direction is not true. That's why this is flow is this direction. That's why it's giving you the negative flow, but that's fine. Okay, all right, so the next thing which pipe with the highest SGL slope? Okay, now look at the pipe table. What is the SGL slope? This is the SGL slope. Which pipe has the highest? The pipe 1 is the highest SGL slope. Okay, and SGL slope in the pipe above, that means this pipe 1, feet per 1000 feet unit. Okay, so what is the SGL slope for pipe 1? Not feet by feet, you have to change the unit, feet per 1000 feet. Okay, if I change it to feet per 1000 feet, then this software shows 6.897. so that's your answer, 6.897. so that's all for your summary table. And similarly, if you can go to the lab question, in this exercise PVC is used as pipe material. So if it is decided to change the material to cast iron, then what will be the impact? Okay, so you have to prepare another summary table. Please prepare a summary table for the cast iron and compare and discuss the result. Okay, so from here material is PVC. If I change it to cast iron, say let's say C, select, now you can see the changes here, right? Cast iron, C, this one. So we have to change everything. So how many pipes we have? 10, right? Okay, so cast iron, C, so look what I'm doing, I'm changing the pipe material from my flex table. Okay, all right, one more. Okay, now everything is cast iron. Okay, the Hazen-Williams C changes. Now let's see, now let's run this model again, analysis, compute. We don't need to validate because we know everything is right? Okay, so now open view to flex table, pipe table. Okay, how much is the flow gradient? So everything is same, right? Flow is 320, 141, but look at here, the last thing, before that it was 6 point something, right? Now it is changed to 8.99. so everything is changed, just the SGL slope is changing, right? Because when the C is, the friction factor is lower, then the SGL will be higher, right? Does this make sense? Okay, now I can close this table. I hope you can complete this summary table. Now look at the question. Now what are the main consideration of Hardy-Cross method? So for the Hardy-Cross method, we know at every junction inflow is equal to outflow, and at any loop the summation of head loss is equal to 0. Now let's see how much is the flow for pipe 1. So go to view to flex table, then pipe table, how much is the flow? 320. And then how much flow for pipe 6 and pipe 2? Pipe 2 is 139 and pipe 6 is 141. Okay, so if you sum them up, because pipe 1 is inflow, pipe 6 and pipe 2 is outflow, if you sum them up, they may not be equal. Why not? There should be a difference of 40 because your house is connected with this junction, so which has the demand of 40 GPM, right? Okay, now look at your lab manual. Which junction has the highest pressure? Of course, from the flex table you can answer this question. What properties of the pipe network would you consider in your design to improve the performance of the system? Okay, so what is our purpose? To design the pipe network. We want to minimize the head loss. If you have more head loss, then it will be inefficient design. Okay, discuss the split between flow in pipe 2 and 6, which I already told you. because your house is connected to every junction. Okay, all right. What is the practical use of this experiment in the real world? Okay, so that's the question. I think you can answer this. Okay, so that's all for the lab 7. Hope you can enjoy this lab. Of course, you can download it anytime and then play with it. Software, that's a very good software. If not, that's fine. Follow the video and procedure, and I will open an assignment section and summarize the WaterCAD software and your work. And that's all for lab 7. Stay safe, stay healthy. Good luck. Okay, so for the report you need to submit an introduction. Okay, so it may include the background and the scope of the experiment. Okay, you can read the lab manual, and then objective, system layout. What is the system layout? When I draw the network, so that is our system layout. Okay, so after, when I remove the background, so when we have network, then that will be our system layout. Okay, just like pipes, pipe 1 2 6 3 4 5 6 7 8, there are 10 pipes, junction, and the tank, what I draw. Okay, all right, you can take a screenshot probably from the video. Okay, all right. Summary of the system design, that is the procedure, how we build the model and how we run the model. Okay, and for the summary table is basically this one. There are two summary tables, so obviously both two are same. One is PVC and the another is cast iron, so both are same, but except this one. So if you just go over the video, and then you should know the value of these two. Okay, and then after the summary table, then you should be able to answer the lab question. So then discussion, and then conclusion. So that's all for lab 7. Even if you don't have the software, just go through the video, take a screenshot from the video or from the lab manual, and write with your own word. That will be enough for lab 7. Okay, good luck.